In this video, I will be going over the section 7.7 Day 1 notes. In this video, we're going back and talking about the irrational number e as a base and its reference to natural logarithms. The natural number e is known as the natural base. It's an irrational number which is approximately equal to 2.71828 and ... It goes on forever. It's irrational, so the decimals go on forever without any sort of pattern, or there's no repetition either. The big thing is it's very similar to pi. So this is an irrational constant, and it's called the natural base because this base shows up in applications in the real life. So when we talk about exponential growth in terms of like compound interest, or if we talk about population growth or cell division or carbon dating in science class, lots of different things use this base e in terms of those applications. So a natural base exponential function is an exponential function where the base is e. And so the natural logarithm is the inverse of the natural base exponential function. So while you can write out log base e of x, there is a more abbreviated version known as natural log of x. So this ln stands for natural log, and it has an implied base of e. So more than likely, you will never see it written out like this. It will always be denoted as the natural log as ln of x. So be wary of that. So the base is always e on the natural log. And the nice part is your calculator has a button for the natural log, that ln right there. We'll use that here in a moment. So number 1 through 4 says write the following in logarithmic form. So this would be ln of 8 is equal to x. Remember, the exponent goes on the end of the logarithm. So then number 2 would be ln of x is equal to 5. Number 3 would be ln of 6 is equal to x plus 4. And number 4 would be the natural log of x squared is equal to 3, which if you want to use the power property, that would be 2 times the natural log of x is equal to 3. And you can reverse that as well. So number 5, if it's ln, that's base e, raised to the x power is equal to 10. And for number 6, this would be e to the 23rd is equal to x. So we've talked about the common logarithm before that has base 10. Common logarithm is used as well in applications, but this one is used quite often. And so it's important to talk about the natural log because we're going to use it in some of those applications. Let's go to the next page here. So we can use the properties of logarithms when it comes to the natural log as well. So for example, number 7, I can use the power property to put that power of 3 back on 10. And I can change this to a fraction because I'm subtracting 2 different logs. So this would be the natural log of 10 to the 3rd divided by 8. So 10 to the 3rd is 1,000. 1,000 divided by 8, I believe, is 125. And so you can leave it as this, or you can change it, to 5 to the 3rd, and then move that 3 out front to have 3 times the natural log of 5, which is a much more abbreviated version than what we have in number 7. For problem number 8, this is all going to be addition, so it's all multiplication. So this is the natural log of 40 times 1/2 squared. I guess I'll use parentheses here. And then times x. So 1/2 squared is 1/4. 1/4 times 40 is 10. So that's the natural log of 10x. And you can do the reverse, right? You can expand it using the properties of logs. So number 9 would be natural log of 5 plus 3 times the natural log of x. And number 10 would be 2 times the natural log of x minus the natural log of 27. And we know that 27 is 3 to the 3rd. And so then I can use the power property to write it out as 2 times the natural log of x minus 3 times the natural log of 3. Though you wouldn't be wrong if you just had that first answer, right? That's acceptable as well. But this is even more expanded in terms of the power property. That's it. That's your video for today.